All right, in this video, we're going to take a look at the three types of solutions that you can have. And the three types here are shown by the picture. And the first is called an unsaturated solution. And so in an unsaturated solution, you have your solvent and you have your solute. And the situation is that there's enough room in the solvent to dissolve more solute. So this could be just an empty glass of water, or just a glass of water. That's an unsaturated solution. If you add a scoop of sugar, it's still unsaturated. As you keep adding the sugar to the water, at some point, for every solute, whether it's sugar or salt or copper 2 sulfate, whatever it is, you'll reach a point where no more solute can dissolve, and you'll begin to get crystals at the bottom of the test tube or glass or whatever. And at that point, you have what's called a saturated solution. No matter how much more solute you add, it just can't dissolve anymore. And the third type of solution is a very fun and a very cool type of solution. And we'll actually look at a video on the next slide that shows what this can do. If you've used a hand warmer, or you remember when I brought the hand warmers in for the thermodynamics chapter, a supersaturated solution actually has more solute dissolved in it than it's allowed to have. And that might seem counterintuitive. How is it possible, if you have this situation, how can you add solute and get more of it to dissolve? Well, the trick is this has to be heated. You can add the solute then while it's hot, and hot solvents in most cases will dissolve more solute. And then when you cool it down, it will be supersaturated. And I'm going to show you a video in the next slide of what a supersaturated solution looks like when you add a seed crystal. All right, in this little video clip, you're going to see a supersaturated solution of sodium acetate right here. And he's going to add something called a seed crystal. And if you've ever made rock candy with maybe your parents or grandmother, it's an older type of candy that was made more in the 60s and 50s. But a seed crystal will allow the sodium acetate a way to grow and the solution will become unsaturated. And here you go. It's fun.
All right. It is April 23rd, 2013. This is the supersaturated solutions demo. This is a supersaturated solution of sodium acetate. Now what's going to happen is we're going to add a seed crystal of sodium acetate, and what should happen is that the whole thing should become a big solid. Just that much. Just this little bit.
Get down here at the bottom.
So here, oh come on, be in focus. There we go. So you can see that it became a solid. That clear solution became one big white solid. And it's actually quite warm to the touch. So this has been the so solid in fact that you can turn it upside down, that solution, and it won't move, budge or anything. So this is the sodium acetate supersaturated solution demo. Thanks to Dr. Olmsted for helping me out with this demo, and thanks to the Grossmont College for letting me use their lab. Thanks. Have a nice day.
So we look here with this picture. This is called, this is a series of what are known as solubility curves. And a solubility curve is just, it tells you the amount of a salt that can dissolve in water at a certain temperature. And so the way to read this chart, anytime you get a graph, look at the X and Y axis first and figure out what they're telling you. So we're seeing here that they're telling us the effect that temperature has on the solubility. And the solubility is measured in grams of salt and 100 grams of H2O, right? So, for example, let's look at NaCl here, this blue one. We see that at 30 degrees Celsius, about 35 grams of NaCl can dissolve in 100 grams of water. Or let's look at lead 2 nitrate. We see that we see that 70 grams of lead 2 nitrate will dissolve in water, at about 34 degrees Celsius. So that's two different ways you could read in this graph. Another interesting thing when you're looking at a graph is to look at the slope of the lines. What are they doing? Are they going up or down? Positive slope. We see that most of these lines are positively sloped, right? So that tells us that the amount of a substance that can dissolve increases as the temperature increases. And this is our experience, right? We know when we have a hot cup of coffee, we can put more sugar in it than when we have a cold cup of coffee. There are a few strange substances. This cerium 3 sulfate, you see, actually goes down in solubility. And there's a reason for these. And gases as well will go down in solubility as the temperature goes up. And it has to do with the energy of the atoms in the water. And it's a little bit more complicated than that, but we'll talk about that in a later video. But for now, I want to make sure that you can read a solubility chart. And the last thing here, and then we'll be done, is how could you use this to make a supersaturated solution? So let's look at, let's make a supersaturated solution of potassium nitrate. Okay, so the green one here. So let's say that we have water at 30 degrees. We can only add 42 grams of sodium nitrate to 100 grams of water at 30 degrees. So if we heat up the water to 40 degrees, we can now dissolve about 62 grams. So if we took our 100 grams of water, we heated it up to 40, we could dissolve 62 grams. Then if we cool the water back down to 30, we see that at 30 it can only hold 42, but it would have 62 grams in it. And at that point, we've created a supersaturated solution. That's a very unstable situation, and all it takes is adding that little seed crystal, and you get that beautiful white crystallization. And it's not always white, but usually it's white crystals. So I hope you enjoyed the video, and if you have any questions, as always, email me, and copper tomorrow.